Hello dear students, today we are going to discuss second PUC Max Determinant chapter 3 marks fixed question. This is new type of question. Every year they won't ask question from this chapter for 3 marks, but due to number of more questions in this year, they are asking these 3 marks questions. So they are asking these 3 marks questions from properties. Okay, whatever properties, there are 6 properties important. This from 6 properties they are asking these 3 marks questions, and I am going to explain those 6 properties with proof today. So watch this video till end, and if you haven't subscribed this channel, you can subscribe it right now. And okay, so let's start. Let us enough. Okay, so first you should know how to find determinants. Okay, you should know how to find determinants. It is very important how to find determinants. Okay, how to find determinants, you should know it very well. Okay, it should know. Now what is first determinants? Let us see what is first determinants means. So I think everyone know what is a square matrix. Square matrix means where number of rows is equal to number of columns, that is 2 cross 2, 3 cross 3, 4 cross 4. These all are square matrices. These all are what square matrices. So the determinant, what is this determinant means? A determinant is a number, nothing but it is a number that may be real or complex, that is associated to square matrix. So this square matrix. Okay, a number associated, the number which is associated with square matrix, the number which is associated with square matrix of order n, square matrix with a square matrix of order n, square matrix of order n, we say that as a determinant. Order n, this order may be 2 cross 3, 3 cross 3, 4 cross 3, but to our syllabus we are limited till 3 cross 3 only. Okay, to our syllabus. In engineering and further studies you will study 4 cross 4, 6 cross 6 you will study. Okay, if you do in MSc there are also 7 cross 7 matrices, but it's in higher level, not now. Okay, just to your class 12 board it is limited to 3 cross 3. Now how to find these matrices? Everyone should know how to find these determinants. See, first in our syllabus I said there is only 2 cross 3 and 2 cross 2 and 3 cross 3. First in 2 cross 2, suppose I am having matrices, determinants. See, now here we write determinants as something like this. Okay, you should not call this as mod, you should call this as a determinants. Now 1, 2, 3, 4, I am having these 4 elements of this determinant. Now in 2 cross 2 just we cross multiply each the elements, like here 1 into 4, 4. Here in matrices what we used to do, in matrices we used to do plus whenever we do the matrix multiplication and all. In determinants we used to do subtraction. Here 4 minus 6 we write. Okay, students get confused over here. Okay, they may use plus or they may use minus. So here the very important thing, in determinants you should use minus sign. That is very very important, yes. Here always try to use minus sign. This becomes 6 minus 6, 6. If you write this 4 plus 6, this is wrong. Why? It is a rule in determinant that whenever you multiply the elements, you should use minus sign. So what I am not understanding where we are using. Suppose I will take one example of matrices. 2, 3, 4, 1. 1, 2, 3, 4. I am taking these two matrices. I am to do matrix multiplication. Now here, if we do first row and first column, something like this. Now 2 into 2, 2. Here 3 into 3, 9. Here what we used to do in between, here we used to add plus sign. And if I am having the here minus 3, then 3 into minus 3 there comes minus, plus minus we used to add the minus. But according to sign convention, here we use the plus itself. If this concept is clear, then you can solve any matrix question. That is very important. This concept is very okay. It is very important. You should clear this concept. Okay, this concept should be clear, where we use plus and where we use minus. In matrices we use plus and determinants we use minus in between two elements. Okay, now here this becomes what? This becomes minus 2. So what is this minus 2? It is a number. It is just a number which is associated with square matrix. This is a square matrix. Okay, this is clear to everyone? Is it clear to everyone? Okay. Next, how to find this determinant? First I told you regarding 2 cross 2. Now 3 cross 3. Okay, let us talk about 3 cross 3. Suppose I am having number 2, 3, 4, 2, 1, 2, 0, 1, 1. Okay, 0, 1, 0. Now here, whenever we solve this 3 cross 3 order, here first thing you should add here plus minus plus. Here we follow the expanding rule. Here we follow what? Expanding rule. Okay, If you know all these things, you can skip and direct go to the properties. But students, many students do not know this basics. So that's I am saying that you should go with expanding rule. What is this expanding means? Here everyone should remember this is R1, this is R2, this is R3. This is a C1, this is a C2. Always remember this is C3. Row is always sleeping. Row is always sleeping. This is the easiest way to remember. Row is always sleeping. Row is always sleeping. Column is always standing. Column is always standing. Okay. You may also think of an example of columns which we where the builders used to use that columns. Okay, to build buildings. There they place the columns. What are columns? These are straight. Okay, straights. Okay. So whichever are straight in this type of, there are columns that you should remember over. Okay, what all are straight now? Those are what? Columns. So here C1, C2, C3. Now here we used to expand along R1. In matrices we used to expand along R1, but in properties we may have to expand along C1 also. Okay, if necessary we have to also expand along C1. Basically now we expand along R1. Okay, we expand along what? R1. So here when I try to say expand along R1, there are 3 elements associated over here. These 3 elements are taken as outside element. These 3 elements, whenever we say that this take associate expand along R1, these are their outside element. What do you mean by outside elements, sir? Suppose, see now here, let me add here 2 here outside bracket. Okay, whatever this element will be associated outside the bracket, not inside the bracket. If I take expand along C1, these 3 elements, okay, these 3 elements, what we say, these are outside elements. Now here 2, now see here 1 into 0, 0. Here always I said you should do minus 2. Between the elements, between the groups, here it depends upon the sign convention. Okay, so here we are taking minus, so I used to keep here minus 3. See here, now we have to delete this row and this row, this column, R1 and, okay, this and this we have to delete now. Remaining elements are 2 into 0, 0, minus 0 into 2, 0. Okay, 0. This element is washed out. Now here plus 4. Here 1 into 2 is 2, 0 into nothing, anything is 0, that is 0. Now what this becomes? This becomes minus 2. See, always remember 0 minus anything that will be comes in minus. Okay, it will come under a minus. Okay, this becomes minus 2. Minus 3 into 0 is 0. Okay, this now we will remove this element and directly will come. This is wash out now. This is wash out. Plus 4 into 2 into 0, it becomes 4 into 2. This becomes what now? This becomes ds. This becomes minus 4 plus 8. Now here plus minus, what is that plus minus? Minus. Here we have to do minus, but we have to use the sign which is associated with the greater number. Here plus is associated with the value which is greater. So we will use the positive value, but we will do minus in nature. It is the beauty of maths. Plus minus minus. What we use, that is plus 4 will be the answer. So why not minus 4? Because the number which is, okay, the sign which is associated with the greater number, we use that sign over here as the answer. Is that clear to everyone? How do we find the determinant? After, okay, if you are clear with how to find the determinant, then we are easy to go with the properties now. We are well and good to go with properties now. Now see, the very first property, very basic property, the value of determinant remains unchanged if its rows and columns are interchanged. What does it mean to say? Means the value, suppose I am having this determinant of 3 cross 3, let us consider, suppose I am having A1, A2, A3, okay, suppose and C1, C2, C3. And I will get one particular value of this, that is, suppose I think this is 8. For example, I am saying to make this understand the property. Suppose I get the value of determinant to be 8 over here. Now once again what I do, I will do the interchange, means I will do something known as transpose. I think you know what is transpose here of the matrices. Okay, that thing is overused over here. So if I change transpose, means here rows are interchanged with rows, columns. Now this A1, this was A2, this was A3. Now it comes under a column. See, A1, A2 and A3, B1, B2, B3. This becomes C1, C2 and C3. And this one determinant we got. Now here what was the determinant? Here the determinant was, it was A1, A2, A3. Here B1, B2, B3, C1, C2, C3. This was the determinant over here. Yes sir. And here is the determinant. the value when I find or expand along R1, C1, anything else, the value which I get, that will be also 8. Why? Because it is a rule or a property of a determinant that if we interchange the rows or columns, then the value of determinant unchanged. It remains unchanged. That is very important. Here we will find out the proof. Here we find out the proof. But in 4 marks questions, you should use it directly. If there is we think that there is a necessity of interchanging the rows and columns, then you should think that there is no need of changing the value. It will be same. Is that clear to everyone? Okay, so let us start with this. Now let us take one. Now this is the proof. Okay, this is the proof I am solving. 1 minute. Okay, this is the proof I am solving. So 1 minute. Okay, see, now let consider a determinant A as A1, A2, A3. What I am writing, if you write all these things in your examination, you will get full 3 marks. B1, B2, B3, C1, C2 and C3. Okay, this is the determinant A. Let us consider, and let me find the value of this. Let me find, and see here will expand along R1. Basically I said the most commonly we will expand along R1, first row, which is row which is always sleeping. Row is always sleeping. This is the row now. So here I'll expand, means this I'll get plus, minus, plus. These are the outside elements. These are outside elements now. Now determinant A is equal to, here you should use one step. Here you should use that expanding along R1 or first row. You can use anything as first row or R1. Here whenever we say that we are expanding along R1, we have to delete this and we have to delete this, both the rows. Okay, this column and this row should be deleted and we should use this. Okay, I am going with a very basic from this. For next example I will do it directly. So here A is equals to what? See here, now first A1 and I will make it 2 cross 2 determinant, that is B2, B3, C2, C3. Okay sir. Now here this is minus A2, this becomes minus A2. Now here minus A2 means we will delete the first row and second column. Now here this is C2, we will delete this and this. So what all are remaining? B1, B3, C1, C3. These all are remaining now. Right? Now coming to plus A3. What all are remaining now? We have to delete first row and third column now. What all are remaining? B1, B2, C1, C2. These all things are remaining right now. Okay sir. Now you should find the determinant of this. Okay, see A1. Now what you have to do to find the determinants? We should just cross multiply in case of 2 cross 2. In case of 3 cross 3, first we have to convert these 3 cross 3 into 2 cross 2. We have to convert it into 2 cross 2. If you convert it, now it will be easy to find the determinant. Okay, you should have a practice that you should directly do this. You should not add this step in your examination. Okay, it will try to save your time. So see here, this becomes what? Now see here, we should simply cross multiply it. This becomes B2 C3. Here always I said use minus sign in between here. B3 C2. Let me check that it's going on now. Yes, it's going on live. Okay. So see, and minus here A2 as usual. Here B1 C3 minus B3 C1. Here plus A3, what it becomes? B1 C2 minus B2 C1. Now keep this value as usual, but you should keep this value with underline or anything. In examination you should remember, you should underline this value. Okay, I am highlighting over here. Okay, you should underline this because this is important. Now this is determinant A. Now this is the value of determinant. Okay, now we are consider one case over here. What these people are doing over there? What sound are they saying? See, let us be. So I will consider one delta 1 as a determinant which is got, okay, which has been obtained by interchanging rows and column. Okay, it is obtained by what? Interchanging rows and column. It is obtained by interchanging rows and column. That is one. Let me consider delta 1 as a determinant which is obtained by interchanging rows and column from A. Okay, from A. That is what, which way? This is the A ds. This is the A. If I interchange the rows and columns over here, I get A1, A2, A3, B1, B2, B3, C1, C2, C3. I get this. Okay. Now this is what your determinant or delt one also we say that. Now here the very important thing, we should also get this a1, a2 and a3 as outsiders in our same also. To get that, what we'll do, we'll make plus minus plus. Means what I'm trying to say, yes, you got me correct, that is expanding along C1. I'll expand along C1, that is column 1. Okay, I'll expand it along C1, that is column 1. So here determinant, okay, what will the delt 1? Here that will be A1. Okay, first what I will do, first I will delete this first row and first column. First row and first column I will delete this. What all things are remaining? B2, C2, B3, C3. B3, C3 are remaining. Now minus A2. Okay, then what will be remaining? First we have to delete C1 and R2 here. C1 and R2. B1, C1, B3, C3. Okay, sir. Here plus A3. What will be A3, dear? A3 will be, first we will delete this C1 and this is R3. That will be what? B1, C1, B2, C2. Now here, very important thing, here whenever you expand, this thing we get correct B2 into C3. But here when we expand along C1, you should, here for a convention we use multiplication like this. We cross multiply like this. Okay, no one knows this reason, but everyone does this. Okay, so here just that is the very important step. Here if you do it something like this, then you won't get your desired answer and you will lose your marks. Here the step should be followed something like this. So here A1 B2 C3 minus B3 C2. Check this. B2 C3 B3 C2. We want to get the value which is in A, okay, or delt. Okay, you can consider this A or you can also consider it to be delt. Minus A2, similarly B1 C3 minus B3 C1 plus A3, what will that? Yeah, B1 C2 minus B2 C1. Okay, sir, clear. Now is that clear to everyone? See now, check the value. Now this and this, both the values are similar. Both the values are what? Both the values are similar, then the properties goes true. The property will be correct now. Okay, the property is correct now. What is that property? That the rows, okay, if interchange means the value of determinant does not change. You can check the value of determinant has not changed. Okay, if the first property is clear, and it's the most, okay, it's equally important also. Okay, the examiner also asked this. Okay, there's a huge possibility. Okay, is the first property with proof is clear to everyone? Is the first property, and here you can say hence delt is equal to delt dash. Okay, you can say like this and you will finish your answer and you will take your 3 marks in your pocket. Coming to the second property, very important and silly property. Property 2, if 2 rows and columns or columns of a determinant are interchanged, then sign of a determinant changes. As so, see here, basically what we will do here. Okay, see, as usual, see here, students, same proof. Okay, what the statement try to say, that same, if we interchange. Okay, what the hell, 1 minute, let me, okay, scold them. Who are those? What the hell they are doing? These are small kids. Okay, just a second, I'll just warn them. I'm taking class. Okay, sorry for that. There were small students they brought from that fair and all. They are starting that. Okay, what a silly students. Okay, where those are, I'm not understanding. Sound is coming now. In mic also I think sound is coming. It's so irritating. Okay, so here see, basically here we are considering A1, A2, A3, B1, B2, B3, C1, C2, C3, and we are interchanging as A1, A2, A3, B1, B2, B3, C1, C2, C3. We are interchanging this. When we interchange this, they are saying that if any two rows, here let me interchange only two rows. Okay, here I interchange three rows. Okay, let me, okay, don't worry, I will interchange any two rows. Okay, it's not like that. Here we'll interchange any two rows. It is C1. I will like do like this. Okay, B1, B2, B3, A1, A2, A3, A1, A2, A2, A3. We will interchange this any two rows. What the value we get? That they are saying that if we interchange any two rows, that the sign of determinant will be changing. Okay, let's see what happens. So see, students, let us take the proof. Okay, now let as usual delt is equals to A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay, this is the delt. My goodness. Okay, let it be. Now you find the determinant, same value we get. Okay, same value get. Okay, as last I did. Okay, the same it is. Okay, in every determinant it will be using. Okay, this value whatever I not, it will be same over there. A1 is equals to B2 C3 minus B3 C2, B2 C3 minus A2 is equals to B2 C3 minus B3 C1 plus A3 is equals to B1 C2 plus B2 C1. Okay, this was the value we got the determinant. Now here you should write that let delt 1 be the determinant, obtained by interchanging the R1 and R2. Here usually we'll interchange the row. They are asking R1 and R3. What will that? If I interchange the R1 and R3, I'll get delt 1 to be C1, C2, C3, B1, B2, B3, A1, A2, A3, A1, A2 and A3. This will be our what? Delt. Okay, this will be our delt dash also you can say, or delt 1 also you can say. Anything else you can say. Let me consider it to be delt 1 or delta 1, anything you can. Okay, so now here very important thing here, see, always in proof the outsiders should be same. Whatever you do, that outsiders, okay, I said what are outsiders? This A1, A2 and A3, this should be outsiders in each and every cases. Okay, so here outsiders to be A1, so we will expand along R3. Oh my goodness, R3, yeah, you heard me correct, R3. So here plus minus plus. Okay, simple, anything, nothing more than that. I'll explain this how to do expand over here. So here delt 1 is equal to what? It will be delt 1. See here delt 1. So here let me go from a beginning again. So here A1, okay, A1, what I will delete? This C1 and R1, R3 is deleted. R3 and C1 is deleted. What all are left? It is C2, C3 is left. B2 and B3 is left. Okay, B3 and B2 is left. Next here minus A2. Okay, what all? See, minus A2 means what all are we are deleting? This R3 and C1 is being deleting. So here that will be C1, C3, B1, B3. Okay, B1, B3. Next plus here A3 means what we are deleting? This R3 and C1 has been deleting. So here what will that? C1, C2, B1, B2, B1, B2. Okay, so we will be deleting and we will be getting this answer. Okay, sir. Now here you should do X. Okay, now 2 cross 2 it's very easy. Okay, 2 cross 2 it is very easy. Okay, if we do 2 cross 2, what I will get? I will get C2 B3 minus C3 B2. Okay, see here as usual you should keep this minus A2. This is C1 B3 minus C3 B1 plus A3. This is C1 B2 minus C2 B2, C2 B1, C2 B1. Okay, we got this. Now compare it with the delt. Okay, compare it with the delt. Now here everything is been opposite. Here C2, here C2, here you can see here B3. Okay, here everything has been opposite. Okay, everything has been opposite. Now if I take a positive sign outside, if I take a positive, now here you can see this C2 and B3, here we call C2 and B3, but here C2 and B3 is over this side. We got over this left side, in that our delt 1, this C2. Okay, let me write that delt 1 as here. You can easily compare that. So let me write the delt 1 over here. This is your A1. This is C2 B3 minus C3 B2. C2 B3 minus A2. Here C1 B3 minus C3 B1. plus A3. What was your A3? That is C1 B2 minus C2 B1. This is our A3, C2 B1 minus. So you can check it over here. Which all should be in left side, here it is meaning right side. Okay, everything. Okay, so here you can also check it. Here B2 C3, here is C3. Okay, everything has been changed. So here, if you are not understanding what is going on here in this last step, nothing else you have to do. If this property has been asked, only step you should do. Okay, if they ask this, then what you have to take, delt 1 is equal to minus, you should take common, and you should write all the thing as usually of this delt. Okay, if you are not understanding what to do, then you should write this as B2 C3 minus B3 C1 C2. Okay, in the last moment if you study, then what will be understanding now? Okay, write the note as usual. I am writing it. Plus A3 is equals to B1 C2 minus B2 C3. Okay, now you write this. Now this delt 1 is equal to minus, this is what now? This is completely delta. So this is as we want. This is the required. This is what? This is the required. Okay, this is the required. Is that clear to everyone? If you are not understanding, first find the determinant as usual and take the minus common and write as usual of the determinant delt. Okay, and you will get the answer. Is that second property clear? Now coming to the third property, silly property. Okay, second was not silly, third is silly. If all elements, okay, of all elements of a row or column are 0, then no, not this. Okay, let me write this. Okay, it's not the property. See, a third property is this. The third property, prove that if any two rows or columns, are identical, if any two rows or columns are identical, then simply you should say the value of determinant is 0. Okay, this is a simple property. You say value of determinant is 0. Okay, this is the third property. This is the third property. Now here what I am trying to say, if check it, okay, they will not ask this proof for 3 marks. So directly I am trying to say, if we are having determinant something like this, A1 A2 A3, and again we are having A1 A2 A3, and here we are having C1 C2 C3, then if this any two rows or columns, or we may also have a situation like this, A1 A2, okay, not A1, let me take the different one. Okay, I am having A1 A2 A3, here I am having B1 B2 B3, and if I am having here I am again having A1 A2 A3. If any two rows, these are two rows, any two rows or two columns of a determinant are identical, same to same copy, then we say the value of determinant, whatever the value of determinant will be, that will be 0. Okay, that will be 0. Okay, you can also prove this. Okay, once you can prove it. Okay, as usual you find, okay, you consider this example and prove that. Okay, you consider this as an example. Okay, this as a one single property and try to prove. Okay, it depends, if they may also ask this. Okay, just once prove it, they will not ask it, but just try once. Why you will take risks over there? Okay, you can also do this. Here the value of determinant will be 0. Okay, directly we say this will be 0. Next, coming to the fourth property, if each element of determinant is multiplied, if each are identical, the value of determinant. So this was this property. Okay, let it be. See, now this is the fourth property. This is the property number 4. If each element of a row or a determinant multiplies the constant k, the value of determinant get multiplied. See, suppose I am having determinant A1 A2 A3, B1 B2 B3, C1 C2 C3. I am having this determinant now. Okay, sir. If each element of a row or column, now this is each element, not each value of determinant. I am saying each element. That is very important. The term element, your basic English is checked over here. Each element, not all the values of determinant. If each element of a row or column, now suppose I am multiplying this with the constant k. Okay, I am multiplying each element of R1 with constant k, then the value of determinant, okay, whatever the value of determinant, suppose the value of determinant A, then the value of determinant will be 8k. This constant k is also multiplied with the value of determinant. Isn't it clear? Is it clear to everyone? the value of k also gets multiplied over here. Okay, so let's do with a proof. So see, let me take one delta as a determinant as usual. See, a1, a2, a3, b1, b2, b3, c1, c2, c3. Okay, this is the determinant I will consider. Now expand. Okay, see, from beginning I said that it will be in each a proof that you should expand this along r1. Expand along r1. What we get here, the determinant is equals to what? a1 b2 c3 minus b3 c2. Okay, in first example I did it. Okay, okay, this is the value we get. Okay, sir. Okay, now what you have to do then, now a should be one delt n, there should be delt 1, there should be delt 1, which is obtained by multiplying the elements of first row, which is obtained by multiplying elements of first row by k. Okay, okay, let me take on delta n now. Here what is the delt 1 will be? That will be k a1, k a2, k a3, here b1, b2, b3, c1, c2, c3, c1, c2, c3. Okay, sir. Now here if you find the determinant, okay, if you find this, okay, determinant, see, now here as you will expand along first row, here you should write, it is very important, okay, where you expand, okay, expand along r1, we get, so now here plus minus plus, so here k a1 will be what? See here, now first row first column is deleted, everything will be same, just see, everything will be same, just this as same, just here the value of k will be added. Okay, that's the value of k will be added over here, everything will be same. Okay, if you do that you will also understand that. So I am doing that, everything will be same as usual above as a delta, just the k will be associated with outsiders. Okay, k will be associated with outsiders. Okay, you can also tell how is the class going on, are you able to understand the class or not? Minus b2 c1. Okay, this is what now we got as usual. Now here what we will do, I'll take k as a constant. If I take k as a constant, I get a1 b2 c3 minus b3 c2 minus k. Okay, now k has even taken constant now, minus here will be a2, so that will be b1 c3 minus b3 c1, here plus a3 will be what? b1 na, yes, b1 c3 minus b2 c1. Okay, the complete value is delt. Now this becomes k into delt. Okay, this is what delt. So this is what delt 1. So this will be delt 1 is equal to what? K into delt. K into delt. This is the required value. Okay, as usual the value of determinant get multiplied by constant k. Okay, I think it's very simple na. These first and second four are very simple. I think you are able to understand all the four. Okay, all the four you are able to understand easily. Okay, next coming to fifth property. Fifth and sixth property. Sixth. Okay, see this property, this is property number 5, not 6. This is property number 5. This is property number 5. Okay, property number 5. What is this property number 5 says? If elements of rows or columns of a determinant expressed as a sum of 2 or more terms, okay, then the determinant can express as the sum of 2. Okay, what is this able to try? This is very important property because in 4 marks all the properties mostly are based on this property number 5 itself. Okay, you can check out the fourth property in the 4 mark questions. Okay, so here what basically they are saying, there is one determinant which is expressed in the form as a sum of okay, sum of 2 or more elements, like a1 plus delta 1, like a2 plus delta 2, like a3 plus delta 3. Okay, a3 plus delta 3. Okay, it's going on 43 minutes. Okay, so they are able to express like this. Now here I will say here is b1, b2, b3. You can consider only, okay, if you want you can also put all the elements, but for ease of examination you can also see like this. Okay, c1, c2, c3. Okay, so we have to, now this is okay. Now what we have to prove here first thing they will not give that to prove that the determinant will be, here it can be expressed a1 a2 a3 b1 b2 b3 c1 c2 c3 plus del 1 del 2 del 3 b1 b2 b3 c1 c2 c3. This you have to prove that. Okay, see, as usual, if elements, if any elements of a rows or columns of a determinant expressed as a sum of 2, it is expressed as a sum of 2 now. Okay, this is expressed as a sum of 2, then the determinant can be expressed, the determinant value which is getting now, it has to be expressed as a sum of 2 or more determinants, as I am able to express. This property is very important in 4 marks. I am repeating it. Okay, it's very important. So here, now this is clear. Is it clear? Now let us expand it along first row. Expand along first row. Expand along R1. Everything will be same. Now here R1 plus delta 1 will be outside. Here inside what will put? See here. Now if this is down this range, this will be deleted. R1 and C1 will be deleted. What will be getting? B2 C3 minus B3 C2 minus B3 C2. Okay, as usual, minus a2 plus delta 2, a2 plus delta 2. Now here you can add bracket or no need. Okay, and here you have to repeat this R1 and C2. You should delete this. This becomes B1 C3 minus B3 C1, B3 C1. Okay, plus A3 plus delta 3, A3 plus delta 3, A3 plus delta 3. And what I will be getting here? 1 minute. Let me take it little bit over here. Okay, see here. Now what this and this will be deleted. What I will be getting? B1 C2 minus B2 C1, B2 C1. Okay, so now check it over here. Now what I will do? Okay, now here according to the sum property, okay, according to the property, okay, not this property, basic max property, as whenever there are two sums, okay, you should always remember, if I am having two sums like a plus b associated with bracket, anything is present. Now this a is once multiplied with this bracket and b is also once multiplied with this bracket. This is the property in max. So I will write this as a1 b2 c3 minus b3 c2 minus a2 b1 c3 minus b3 c1 plus a3 b1 c2 minus b2 c1. Here next what I will do? Next I will express this. Now this I will completely express in the form of delta now, plus delta 1 I will take, delta 1 b2 c3 minus b3 c2. Okay, as I say that property, minus delta 2 b1 c3 minus b3 c1 plus delta 3, that will be what? b1 c2 plus, sorry, minus na, okay, minus b2 c1. Okay sir, now here these are, now here let me take this separately. Now if I want to write determinant of this, what will be the determinant for this? This see, a1 a2 a3 are outsiders, so this will be upside a1 a2, and remaining here b1 b2 b3, these are insiders. Okay, these are what? Insiders. So let us write it as usual. This is b2, this is b2, this is b3, c1 c2 c3. Okay, these are all insiders, plus here what are outsiders? Delta 1 delta 2 delta 1 delta 2 delta 3. Okay, sorry, lambda, why I am saying delta 1, lambda. Okay, lambda, and here b1 b2 b3. Okay, c1 c2 c3 are, okay, this is what we have to require to prove over here na, and hence it is proved, okay, hence proved. You should write simple, okay, very simple, but for 4 marks it's very important. Hence proved, okay, hence proved we can see. Okay, hence proved. Is it property clear to everyone? Next, coming to the last but not least, okay, last but not least property, that is if each element of any row or column of a determinant, okay, if each element, the equi-multiplier of corresponding element of other rows are added, then the value of determinant remains changed. Okay, let me write the statement first, or let me type the statement first. Okay, so what is that? Okay. If each element of any row or column of any row and column of a determinant of a determinant the equimultiplers. Okay, now this is and the equimultiples. Okay, I am saying what happened, man. Equimultiples of corresponding elements of other rows or columns are added, then value of determinant remain same. Okay, remain same. Okay, it took time, I think so. Let it be. So you see what they are saying. If each element of any row or a column of a determinant, okay, the equimultiplers. What are these equimultiples? Okay, everyone should understand what is this equimultiples. Like in previous example, we took some equimultiples like see, these all are equimultiples. Where is gone? These are called equimultiples. Okay, these all things are called equimultiples. Before itself they are equally multiplied. Okay, so here if the equimultiple of corresponding elements of other rows, okay, this is rows or columns are added, then the value of determinant remains same. Suppose let me take one determinant as delta. It is a1, a2, a3, b1, b2, b3, c1, c2 and c3, and let me take on another element like that a1 plus here kc1. This is equimultiple. a2 plus kc2, a3 plus kc3. Okay, this is b1, b2, b3, c1, c2, c3. Okay, this is what I take delta 1. Now here you should do some elementary operation. This how this delta 1 is obtained, you may ask me. This delta 1 is obtained by elementary operation, that is r1 plus k into r3. This is obtained by this. Okay, since now what we will do, we will apply property number 5. What the hell? By property 5, you can write this delta 1 as a1, a2, a3, b1, b2, b3, c1, c2, c3 plus k c1, k c2, k c3, b1, b2, b3, c1, c2, c3. Okay, c1, c2, c3. Okay, now here what I can do, that here I can take the k as constant. Okay, I can take k as constant. If I take k as constant, a3, b1, b2, b3, c1, c2. See, this determinants I am not interested to teach to pen tablet. Okay, on board it is interesting to teach now. Now here I'll take k as constant. What will, if I take k as c1, c2, c3, b1, b2, b3, again c1, c2, c3. Now here which property is applied over here? Anyone can say it. Property number 3 is applied over here because two rows of a determinant is same. Then here the value of determinant remains what? 0. So again I will write this a1, a2, a3, b1, b2, b3, c1, c2, c3 plus k into 0. Anything multiplied with 0, that will be 0. So here delta 1 is equals to, this will be complete will be 0. So this will be a1, a2, a3, b1, b2, b3, c1, c2, c3. Okay, now this is again equal to delta. So here the proof is, then our value, then that's here. if each now are added, okay, corresponding elements of other rows or columns are added, then the value then value of determinant remains same. As usual, it remains same. Okay, are this all proof clear? I think last two because it becomes hurry bigly, but because writing mostly, okay, let it be. Whatever are done, it's okay. So now we have completed the properties. Now these starting three properties are important, and see, property 1, property 2, property 4, property 5 and 6 are important, okay, rather than 3. These are important. The remaining are also important, but these are important. So thank you for today's class. Then see you with a new amazing video. Till that, keep learning, keep growing.